In this video, I'm going to show you how to calculate unstandardized and standardized residuals in a bivariate regression case. I'm not only going to show you how to calculate them, I'm also going to show you something about the nature of regression in the process in terms of using the regression equation. So in order to get unstandardized and standardized residuals, click on Analyze Regression Linear and Education in the independent variable and earnings per day as the dependent variable. And if you click on Save, you get the option of getting residuals unstandardized and standardized residuals. And actually, you know what? I'm going to click on unstandardized predicted values as well. So click on Continue and click OK. And SPSS does the regression analysis, and it gives you a residual statistics table, which is just the descriptive statistics associated with the three variables that were created by SPSS in this process. So you can see that pre_1, that is the predicted value of case 1 based on education 17. That person is predicted to earn $143.34 a day. And the way that SPSS calculates that is by simply using the regression equation formula. So in this case here, we have unstandardized intercept 13.976 and the unstandardized beta weight of 7.609. So this means that if somebody has 0 years of education, they're earning $30.98 rounded. And for each additional year of education, we'd predict them to earn an extra $7.61. So let me actually show you how that can actually be calculated. Go into Transform Compute, and I'm going to show you how I can calculate predicted values. I'm going to, by hand, BH for by hand, predicted_1 by hand, and it starts with the intercept, which is 13.976 plus the product of the unstandardized beta weight and the values that I actually want to estimate those for, which is education. So it's education variable, I should say, multiplied by the unstandardized beta weight, 7.609 multiplied by X, and education is each individual education score. So for case 1, 17, case 2, 18, case 3, 15. This is going to calculate a predicted score based on the regression equation formula that I'm applying here. So click OK, and what we get is exactly the same thing. It's just created this predicted_1 by hand, so to speak, variable, and it's the same result as I got here automatically from SPSS. So that is how you can use the regression equation to predict each person's score. Now, the reason we do a regression equation is not to predict each person's score on earnings, because we actually know what they earned. We have everyone's earnings here, and we can see that there's a pretty big difference between what we predicted based on a regression equation and what actually was the case. Look how much of a difference. $143 per day is the prediction here, but really this person earns $35. This person, $151 rounded, they earned $63. And if we go down here, this person was predicted to earn $120.51, but they actually earned $280. So we can see that there are very large discrepancies between how much somebody earned and how much we predicted they earned. And that difference is the residual. So what they actually earned minus what they predicted is in fact the residual. 35.08 minus 143.33618 is negative 108.25. So if I calculated the difference between earnings per day actual data and what I predicted based on the regression equation, I get the residual, and that's the unstandardized residual. We can also create these unstandardized residuals into ZScores by simply getting the descriptive. Let's put residual here. Unstandardized residuals, save as a standardized residual, and we get the ZScores as residuals. Now, the reason this is important to know, I think, is first, you'll have an understanding of what regression is and what residuals are. because we're building a regression equation to predict scores. We have actual scores and we can find the difference, and the difference tells us the magnitude of errors that we make on average. And they're quite big in this case because we're only accounting for about 11% of the variance in the dependent variable. You remember that correlation of 0.337? Well, squared, that was something like 11.3% of the variance. Now, the other reason this is potentially useful, you'll see in the chapter devoted to semi-partial and partial correlations. Well, in essence, those analyses are based on residuals. And one way to think about residuals is decontaminated of its influence of education. So this is like a pure measure of earnings independent of education. Now it's going a little bit further than you need to go to in this chapter, but like I said, in the semi-partial correlation chapter, I'll take that to another level. So this is how you can calculate residuals in SPSS, and it's a bit of the background of how they're calculated.